Hi, this is Mrs. Bazin, and today we're going to talk about limiting and excess reactants. So when you have a chemical reaction, you have a limiting reactant and an excess reactant. So the limiting reactant is the reactant in a chemical reaction that runs out first. So it limits how much product can be produced. When this particular reactant runs out, the reaction stops. And the amount of that limiting reactant is what you use to calculate how much product can be produced and how much of anything else is used in that chemical reaction. The excess reactant then is the reactant that is not completely used up, and it's the one that's left over after the reaction is complete. So when you visually look at a reaction, if you can actually see the molecules or the compounds, it's not as difficult to figure out what's limiting and what's excess. So if I look at this reaction here, this equation tells me that for every 2 moles of NH3, I need 1 mole of N2 and 3 moles of H2. So if I'm going to make 2 NH3s, so if I'm going to make 2 of these, then I need 1 N2 and 3 H2s. Okay, so if I look at what I have available, I can make 4 NH3s because I have 2 sets of an N2 and 3 H2s. So you can see over here, there's 2, and then here's the other 2. So then if I look, I can easily see what the excess reactant is and what the limiting reactant is based on what's left. So if I look from left to right, the substance then that ran out or prevented me from making more NH3 was the H2, because all of the H2s that were initially available got used up. What I had left was an N2. So if I had had more H2, I could have continued making the NH3, but because I didn't, the H2 was the limiting reactant and the N2 was the excess reactant. Now where it gets a little more complicated is when you actually have to calculate what the limiting and excess reactant is. So we are still going to use the stoichiometry that we've used so far, but we're going to use it to figure out what's limiting, what's excess, how much of the excess is left, and how much of potentially other products are formed. So when you look at these problems, the way you can tell that you have to do a limiting and excess is they're going to give you 2 numbers, and it's going to tell you how much of each of the reactants you have. So if there were 3 reactants, it would give you the amounts of all 3 reactants. So these are a little different than the ones that we were doing, because the ones we were doing before, where we only had 1 amount given, that was the limiting reactant. The other reactants that they either didn't mention or they said there were excess of, we didn't need to worry about. Well, since in these reactions they don't tell us what's limiting and excess, we have to figure that out first before we can figure out how much product is formed. So this says those 2 are mixed to form ammonia. So this is the same reaction that we visualized on that previous slide. I want to know what the limiting reactant is, and then I also want to know how many grams of ammonia are produced when that reaction is run. So when you set these up, what you have to do is 2 calculations. So my first calculation, I'm going to take 25 grams of the first substance, and I'm going to go from grams of N2 to grams of NH3. So this is the same thing we've done before. So grams to moles to moles to grams. So same method here. Mole ratio, 2 moles of NH3 for every 1 mole of N2. And then back to molar mass, 1 mole of NH3, 17.04 grams of NH3. And that could produce 30.4 grams of NH3. Okay, so what this tells me is if I started with that 25 grams of N2, I could make 30.4 grams of NH3. Now I'm not finished yet because I don't know if that is the correct answer or not. So what I have to also do is I have to start another equation with the 5 grams of hydrogen, but I'm going to take it to the same product and see how much I could make if I started with that. Same process here, grams to moles to moles to grams. This is a 2 to 3 ratio. Last step, go back to grams of NH3. Okay, so this gives me 28.1 grams of NH3. Okay, so when I look at those two numbers, only one of those numbers is correct. So I'm going to take each substance they gave me to start with and do a grams, moles, moles, grams to the same product. Then I'm going to analyze these two numbers and I'm going to look for the one that makes less. I'm going to circle the one that makes less and I'm going to cross out the other one. What this tells me is whatever I started with to make the smaller amount is my limiting reactant. The other one then is my excess reactant. So to answer this question, how much ammonia is produced would be this amount right here, the smaller of the two, because that tells me that that hydrogen is going to run out and cause the reaction to stop making NH3, and this is all I could make. So H2 is the limiting, N2 is the excess. And again, the one of those that makes the smallest amount, whatever you started with, was your limiting reactant. Okay, if there was another product and it asked about another product, then I would start with, I wouldn't have to do two problems again, because once you know what the limiting reactant is, that's what you're going to start the rest of the problems associated with that equation with. Okay, the other question that could be asked, so this is the same amount as the previous one, how many grams of the excess reactant are left? So from that previous problem, because we're starting with the same amounts, if the amounts change, you have to redo the calculations, but these are the same amounts as the previous one. We already determined that hydrogen was limiting and nitrogen was excess. So I'm going to go ahead and label those just as a reminder. So if I want to know how much of the excess is left, then I need to run one more reaction. So before I do that, if it asked how much limiting is left, that's going to be 0 grams, because the limiting is the one that's going to run out. So anytime it asks how much limiting is left, no matter what the problem is, it's always going to be 0 grams. But to figure out how much excess is left, you have to figure out how much was used. So to do that, I'm going to do a calculation from the limiting reactant to the excess reactant to figure out how much was used. So I'm going to start with my 5 grams of hydrogen. And I'm going to take that to grams of N2. Okay, then in grams, moles, moles to grams, just like we've done over and over again. Okay, so this calculation gives me 23.1 grams of N2. And this tells me this is how much was used when I ran this reaction with that limiting reactant. So to figure out how much is left, I have one more calculation to do. So I started with 25 grams. So there was 25 grams of N2 available. I used 23.1 grams, that's what I just figured out. So I have 1.9 grams of N2 left. So that's what I have left after the reaction is complete. So again, how much limiting is left is always going to be 0. How much excess is left? I'm going to start with the limiting reactant, run it to the excess reactant. That tells me how much is used. I go back to the problem to figure out how much of the excess I started with, subtract the amount I figured out that I used. That tells me what's left. So you can tell these problems are a little more complicated than the ones we've done before. You really have to pay attention to the wording and the problems. You have to make sure that you are putting the right numbers with the right substances. Labeling your answers is a big part of this. So you want to make sure you don't just leave that as 23.1 grams. You mark it as that's how much was used. That way you know what to do with it next. As soon as you know what that limiting reactant is and the excess reactant is, I would label those in your equation. That way you'll have an idea of what to start other calculations with. We will go over lots of these in class, so this was just one example to run through. We'll do several more in class, and we'll spend a lot of time practicing these in class as well.